Hello, K-Mac here with another episode on Qumulo technology. Today, I'll be discussing Global Namespace, or GNS for short. This is a new capability currently in private preview. This is also video number 1 of a 3-part series on GNS. On screen is the environment setup. On the left is an on-premises Qumulo cluster in our lab in Seattle. On the right, we have an Azure native Qumulo cluster, which is acting as a long-term archive for PACS or VNA in this fictitious scenario. The ANQ cluster is running in the Azure region, West US2, about 200 miles away. We're going to be setting up a global namespace portal between the Azure cloud in West US2 back to the on-site Qumulo cluster in our Seattle lab. In this scenario, the long-term archive data is written directly to the Azure ANQ cluster, and we are enabling access in Seattle for archival retrieval purposes for both applications and humans alike. With GNS portals, any Qumulo cluster can connect to any other Qumulo cluster, whether they exist on premises or run in the cloud. For a given relationship between two, called a portal, one of the clusters is known as the hub, the true source of data, and the other cluster is called the spoke. This relationship can exist both ways using two different portals from a configuration perspective. The PACS VNA serves as a central repository that could be connected to any hospital or any clinic, regardless of geo-proximity. The change in your PACS ISV software is simple and easy. Qumulo is HIPAA compliant, and no application code level changes are needed. It is just a new mount point. So on screen you can see the on-premises Windows host where I'm connected to the on-premises cluster. Over here on the right you can see the Qumulo console. There's no SMB shares, not much activity going on. So I'm going to run this command here to get us started. QQ portal create, and then I specify the spoke root of portals, a directory to hold the portals, PACS archive. Got to specify the hub address, and that's the address for the ANQ cluster in the cloud, and then the hub root, PACS archive. That's going to be the root over here in the cloud of the production share. All right. I enter that and we get a pending status. The reason it is pending is we have to go over to the hub and accept it or authorize it. So over on the hub, we have I'm going to list the portal hubs here from this perspective, and we do see it with ID 5. So next we're going to authorize the creation of the portal. And that is done. So now we have a portal in place. To test the portal out, I have created an SMB share on the on-premises cluster. I've mapped it to Azure PACS archive right here, and we can navigate the same structure that exists over in the production share. So on the ANQ cluster in the cloud, I'm going to do a test. So I'm going to go out here to the archive itself. I'm going to create a new directory. So let's just create a test directory and let's copy a file into it. So we have a anonymous CT scan right here that I am going to copy into that test directory. Pasted. So there it is. So now in the on-premises cluster, I just need to refresh. Do that by going out and in. There's the test. There's the anonymous CT scan. I pull it up, and we have a picture of somebody's brain. Maybe somebody you know. The initial read of the file required the 4K blocks to be pulled across the WAN connection, which, in your case, the speed's going to depend on the size of the file, the throughput and latency of the network connection, things like that. In this case, it was a small image, so it was pretty quick. My setup has a physical cluster in Seattle and an ANQ cluster in the east, about 200 miles apart. Once a file is read, it is cached on the spoke cluster. It's on premises in this case, making any subsequent reads just as fast as local. Quick note on the technology. Qumulo has developed an advanced data consistency technology which ensures file content is current on the spoke when it's observed. If the source file gets updated, any subsequent read of the file on the spoke will fetch the changed blocks from the hub. This is only to have synchronized data when needed. So that is at the time it is read. So let's do a test. I'm going to create a 1 gig file. I got a dd command here. It'll just take about 6 seconds to run, and we'll get that file created. Next, we want to see how long it takes to read that file. So I'm going to cat that file out to dev null. It took 1.1 seconds. However, that's reading it from cache on the Windows client, so it's not really fair. I'm going to go ahead and, if you look at the map blocks right here, I'm going to clean these up in Windows, empty in the standby list, and giving this a refresh, and we should see the active mapped files drop down. Okay, Windows cache is now clean. Rerunning the test. This is going to be for a baseline. Okay, it took 2.9 seconds to read the file on the source cluster. Now, let's go read it on the spoke. So here on the spoke, in the same directory, I'm going to time catting the file out to dev null. And this is going to be the first read of the file on the spoke. It's going to take the amount of time it takes to pull the blocks of the file across the WAN. I think it was 20-30 seconds last time I tested it. Okay, 28.9 seconds, about what I figured it would take. Subsequent reads are going to be pretty fast. Now, again, this is going to be cheating because we have the Windows host cache. I'm going to go out here and clear this cache. Okay, that dropped the cache down significantly. Let's run the test again. Now this is running on the spoke, and it took 2.7 seconds because the blocks are now cached on the Qumulo cluster of the spoke. Up, I have the architecture diagram back up to talk about what we did. If you take a look at this pink path right here, this is going to be the GNS portal to the archive in this case. So all of the archived long-term retention files are stored in Azure. When they need to be read, users or applications will read the files as if they are local, and the blocks will come over across that pink portal to the production cluster in this case. This is just one example. There's lots of ways to use the portal. I have 2 more videos coming up. Stay tuned and have a wonderful day.